I did post this out, and this was when I took a look at the engineering, their video. This is the original one that we saw, which seems to be taller. So it looks like they made it a bit smaller. But the other thing that's important is how radically they changed the hip. So we just kind of talked about those three different axes you want to have in the hip. And there's different strategies to whether the stride axis is your first axis or whether it's down lower, because that way the mass of the motors that are doing the abduction and the rotation are not being carried by it. It makes it easier for it to swing back and forth. So if we look over here on the original engine AI, we can see the, the, the stride axis is that red axis right there. And the other axes are up here and they're very high. They made their hip very, very high, because if you make it at the normal hip level, then this becomes so short, it's really hard to do it. Now, the knee, you thought that knee is important, right? I'm saying, well, it's kind of needed, but it's absolutely not indispensable. Absolutely not indispensable. Because I want you to stand up right now and walk around your room without bending your knee. Can you do it? So if the point of your leg is to walk, you do not need a bending knee for bipedalism, or at least, you know, you need it for efficient bipedalism, or you can get around without it. So you're putting that kind of in optional. And then let's go in the toe width. This one here, the rotation, that roll. Um, where do you think that lies?
I think it's toxic for me.
Okay, put it in.
You consider it to be rotation
Mhm,
in the
mhm.
hip, right?
Yep. Okay. Yep. And now the knee, indispensable?
The
Yeah.
knee. Of course, yeah.
Okay. Indispensable. And then that means that the pitch would be needed. Without it, it wouldn't be. You wouldn't have a knee. Okay. Now there we come down to the ankle.
Mm.
Indispensable, needed.
And of course, indispensable. Yep.
Okay. And now that we have these 3 degrees of freedom here, down at
Yeah.
the ankle where you can rotate. One is that you could, so the X here, um, it gets a bit confusing when they get down to the feet where they sort of call these different things, but sometimes it's called the roll. X is usually a yaw, but in this case, you're kind of rolling your foot. And we all know what it's like rolling your foot. It's like when you walk down the street and there's a curb and you don't see it, and like one side of your foot is on the curb, the other side isn't, and your foot rolls, and that's how you usually sprain your wrist or your ankle. So we all kind of know these things from injury. So that's the rolling axis. And how important do you think that is?
Hmm. I think it's indispensable if you
Okay,
have
so that,
to
that's,
have
that's
this
indispensable.
function.
Then you get the pitching, which is the flexion, which is the foot kind of going up and down. So we're kind of used to that when when you're running or something like that,
Hmm.
or going up an incline that your foot might be something like that. So is that also indispensable?
Indispensable.
Indispensable.
Yeah.
Okay. And then we have abduction, which is basically the roll about this foot here, or about this line here, very, very much like up here, except it's on the lower leg. You would have the rotational axis along there.
I think it's optional. Yeah.
Okay, optional. Okay, so go ahead and hear. All right, so we've got all those things in there.
I'm
Hmm.
yeah.
And
I'm feeling nervous to see the answers.
okay,
So
well, see, the thing is, there's no right or wrong answer. This is what I want everyone to, is like. This is an exercise you need to go through, and it's not about a convincing me. It's about convincing you. So if you're the designer and doing something like that, it's I'm just playing devil's advocate in many ways. And what I'm trying to do is to say, hey, what you want to do is you want to think this through, and you may or may not disagree with me. Okay, so the head is optional. So you were kind of like it's sort of needed. I mean, we're kind of close there. I'm just like it's optional. You may not need it, but if you do need it, oh, of course I should put it in here. If you're going to need it, you're going to need a neck jolt, right? Well, that's also optional. So you may not even need it because you could just say, we're just going to put this blob on top of the head. This maybe left to right. To me, that's toxic. You don't need it. Everyone that does have it, there are a few that have it. And the reason they put it in is one reason only. And that is emotional attachment to people. They say it somehow needed to make a more human connection between the bot and that. I joke that you only need this for being able to do a header in soccer. It's to me, it's toxic because it's wasted power, it's wasted mass, it's wasting your design. And I did see the Tesla bot up close at the 1010 event or the We Robot event, interacting with it, stuff like that. And even though it's telerobotically controlled and stuff like that, if you imagine for a second that is actually what it's going to be like in AI, and it's actually chatting me that way, the fact that it never did this with its head did not bother me one bit. It was able to do this, was able to do that, it was able to do like enough movement like that that I didn't miss the fact that it could not go back and forth. So to me, it's like, all right, everyone thinks they need it for emotional attachment. I completely disagree. So I think you are unnecessary. So we're kind of close. We're kind of close. But I'm really like, it's toxic. Okay. And I know I'll have some pushback from some people who put it and say, hey, no, 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 no. It's, we'll agree it's optional, but you ever tell us that's toxic. Okay, it's toxic. Now, when it comes to yes, and when it comes to no, I'm no for yes and yes for no. Okay. So the pitch, it's kind of unnecessary like that, because usually you'll have a pretty good field of view. And this one, the location can also be pretty important. Now we're gonna again, we should have a lively little argument here, but part of the thing might be your hands are up front here, and as much as you'd like to use the redundancy and the movement of your torso, assuming we decided to have our cursor rotate, a lot of times if you need to pay attention to something, you want to be able to turn your head over to say, oh, what's going on over there? Maybe, maybe not. You could argue, well, it's not going to be one of these things I need to look over to see what's going on because I heard a sound. If my everything's in front of me, here's my hands. So you could give a pretty strong argument to say, um, this. Oh, sorry, I get this. Which one did I put in here? Yes, yes is up and down. No, I'm saying yes to. So it's indispensable. You could argue that I'm wrong here if you want, and say maybe it's not quite that necessary. But again, for this now, if we remember the ketchup going in the fridge in the figure example, and let me bring that up because I think I have that image here. Uh, you can just kind of bring it up for a second, and I'll remind everyone here of exactly what our in out principles guide is here. Um, Look at what they're both doing. Oh, he's definitely looking up at that. I mean, he's gonna see it, and of course, he's doing both. He's like, "Not only am I looking up at the ketchup, I'm looking to my left and right." So, just looking at this example, we might be saying, "All right, maybe it's needed." But again, you might think, "Oh, all of these are 2 bots working together, and the factory environment is doing this and that." What if one bot at home? Okay, but the the bot's not coordinated with another bot, but the bot might be coordinating with you, right? So if the bot's coordinating with you, it's sort of the same thing. So I might be contradicting myself here. Oh, let me go back to the image. Yep. Sorry about that.
Yes, I want to appreciate because this exercise that you give it to us now, I think it just make it us clear how this really complex this movement, how many joints there's moving, the head, the shoulder, the wrist, the whole thing. I think. And do you think maybe I want to ask you, basically this, do you think there's other way they can do it in a simpler way than the way they're showing here? Because it seems very
So is there a simpler way for us
yeah.
humans to do it? I mean, that's almost what you should be asking. Is it we could build a different mechanism that doesn't look like a human that maybe is more efficient or better at putting ketchup into the refrigerator, but I'm not sure it's going to be good with folding laundry. Um, so the and the big thing about the head is like, well, let's just make it like a fly, right? The eye of a fly has got like thousands of eyes on it. Just like put cameras all over it. And you never need to move the head, right? However, it probably is more costly and more complicated because you now have to take all these video sources and then splice them together and figure out what's going on. So in many ways, you're making your compute harder, and that's why a lot of them have actually moved away from the cameras. It turns out to be too much data. Because remember, this thing's got to run off a battery and do all this other stuff. So you want to limit the amount of compute, and every camera you're putting in there is requiring a little bit more compute and also stitching together the video feeds to make kind of sense out of it. So that's part of the reason. And the other, of course, is it looks more human-like and it can, nod and make a couple of expressions here and there that we can communicate with. So these are tough calls, and some of them are not a pure engineering call. Some of them is like, well, there's a bit more nuance on here. We got to remember it's going to be interacting with people. It's got to be soft. It's got to be friendly. Everything else. So um, now going back to the PowerPoint. Oh, not the PowerPoint. Sorry, the Excel here, and you can sort of see where I am on the neck. So that's where I am now. Let's get down to the shoulder. Of course, it's important. And the shoulder joint is one of the most important shoulder joints of all. You absolutely need it. And you definitely need the yaw and the pitch. The roll is kind of optional. So we're almost, I mean, we have a slight disagreement, but not by much. And it's, again, these things kind of come in shades. And a lot of it depends upon what you really need to do. So if you, and we'll understand what the roll means in just a second. Now, I'm going to surprise you here for a second. You're going to say, wait a minute. The elbow is like it's needed, but it's not important. You can actually function without it. It's like, well, yeah, you can kind of function without it. It'd be really hard because remember the idea of needed is function, but you severely limit the capability. So as far as the shoulder is concerned, what it does is it helps aim your position in space, where you're trying to be. Okay. So the whole idea is that I need to get the center of my hand to some location in space. And by moving this in like two different rotations back and forth, like so, I am able to position it someplace in space to get where I need to be. Now, what does the elbow do? Well, the elbow has nothing to do with actually pointing the arm in a certain direction, even though it does complicate the pointing of it. What it does is it changes the length between my shoulder and my wrist. So the whole point of the elbow is to change the distance between the center of wrist and it's not to actually point it anymore. Now, unfortunately, there's a side effect of the elbow that as I move the elbow, I've missed my pointing and my shoulder has to make up for the fact that I just missed it. So what I'd like to do is be able to make everything kind of go in and out. And you see my shoulder and elbow have to kind of coordinate together to do that. Okay, so this forms a type of robot arm that sometimes is called like a Scara arm that they've come up with, a four-axis arm that uses the elbow to go back and forth. But there's also a spherical arm. And the very first robot, first industrial robot, which was the Unit 1, that was basically a spherical robot. Now, if you think of like the movie Star Wars or some of the Second World War battle scenes where you have the guns that go, the whole idea of those things was to point them in a certain direction. So they had a turret that could not only go back and forth but could point up. And then they were just shooting something off, and basically, you try to make that thing as long as possible to get to where you're going. And that's what the robot was doing. Is it's like kind of pointing around and then just extending in and out. And it was a telescoping joint. So the arm actually went in and out like that. Now, I'm not really aware of any biological mechanism, at least in, mammalian large scale animals, maybe down at really small level, where you have a limb that's able to like just stretch itself out and come back in.
It's chameleon, I think,
You
the
know,
tongue,
but-
chameleon tongue.
yeah, maybe like, but even then, they wrap up or do something like that. But I'm not really sure aware of a joint that telescopes. It's like you'll see ET in the movie how his neck goes whoop, up and up, up, down. It's like, but I haven't seen anything in biology that would be equivalent of a linear joint. Biology has figured out rotational joints and that's it. So in order to get that extension, the only way you can do it is you need to have the elbow. But as I've kind of said, it's like there's another way of kind of doing it. So if we want, we could redesign our arm and say, oh, wait a minute, let's just have a telescoping joint here. And it would have the same effect. As a matter of fact, it would be better when I get over to a certain location, my wrist would be kind of pointed in the right direction. Whereas a lot of times with my elbows like this, and I need to get my wrist pointed at, it's really hard. I've got to do something else to get better around. So so why not have this? So, well, there's a good reason for that. And that is if, I'll just take something like this, it's like I've got something that's blocking me. And if I need to get to this side of it, I can reach around it with my elbow, right? Whereas if I had something straight, oh man, I'm like, I can't get the arm through there. So in many ways, especially if you want to do the plumbing in the house, you want to have an arm that has it. So there are advantages to having the elbow. So it's one of those things that's needed, but like I'm saying, it's not something that is so important that absolutely has to be in there. And we're going to come to another joint where we kind of can make the same similar argument, but almost on stronger terms. So that's kind of looking at that particular, what's going on and what the whole point of the elbow in the first place, and what's going on with it. The next thing to think about is if we look at then the other wrist joints in what's going to be there. So we have on the wrist, I'm saying that the wrist is optional. And you might be like, wait a minute, we're really disagreeing here. Okay. And the reason it's optional, it kind of depends on what you're doing. So if you're lifting up boxes, like what the agility bot is doing, you don't need a wrist. All you need is something wrapped around your hand that you can come in, you can lift up a box and move it around. That's why I'm saying it's optional. So you can get, and you were also mentioning that Unitree doesn't appear to have it, because what Unitree is trying to show is that they've got a kung fu bot and they can run, do all these other things. They don't want you to realize that they don't have a working hand, but they want to impress you with a locomotion, which is impressive. Okay, but they don't have the rest of the bot there to make it really really useful. Okay, so then when we come down to it, I'll start at the top, and that is, the yawing here is optional, completely optional. Could even be considered, you could even say you if you want, but I think I'll leave it in as optional. So it's almost unnecessary. The pitch extension is very important, kind of going up and down. And also the doorknob movement is necessary. It's definitely very, very, very necessary. So those two kind of have to go in. And this one, the abduction can go out. But when we start talking about these things, it depends. Do you really need a hand that's doing lots of complicated things? If you're doing things that are just kind of lying in a plane, doing very simple things in most industrial robot settings, you can get away with taking a degree of freedom or two away from your wrist. If I was going to take a degree of freedom away from the human hand, it would be this one. And the reason is we barely use it. You see, and not only does it cause injuries if we use it too much, it doesn't go very far. So this is almost a hint. Because it barely moves, you don't need it. This one, we do use quite a bit. And you could also say this one we use quite a bit because we can see the range of motion that's in there. So they're both kind of important for that reason. And if you want, and it's rather interesting, both you and I were like opposite on that one, but that's all right. Uh, so we have that. Now, you can get away without the abduction of the hand. Because a lot of times it's just putting your hand down flat on something, and it may not be that important what you're doing here. And if you have the shoulder roll, you don't need this one. This is because remember, this is 7 degrees of freedom. You really only need 6 axes. So you and that's why this one, you said it's necessary, and you could almost strongly write. I'm saying it's kind of optional. You may not need it depending upon whether you want to have your elbows always straight down. If your elbows are always going to be straight down, that's fine. But if you want your elbows to be able to come up, and then again, I'll sort of show what's going on there. Is your if you want to keep the hand in a certain position, orientation, and space, I can move that, right? And I can only do it because of that Z rotation that we have that allows me to move the elbow. If you take that kind of out, that means I'm always like this. I'm very mechanical, and I can never, well, I can be able to get up that, but I wouldn't be able to kind of flop them around a little bit. So it takes a little bit of movement away from your elbow to get the redundancy you need. But if you have that redundancy, you almost don't need that in the wrist. So these are kind of the close calls you're going to make. It's like, okay, what is our household robot going to do? Is it going to be doing like, the plumbing and electrical and stuff like that, where maybe you need some of that extra little nuance in there? Are the kitchen tasks it doing fairly straightforward and simple, or is there some like really weird kind of into the knife kind of stuff that's going on that maybe would help to have it? And maybe that can get away with that. Maybe not. Maybe trying to get that jar of mayonnaise in the back of the refrigerator requires your wrist to have that little extra movement to be able to go ahead and grab it and pull it out. So it depends upon where we want it to be able to function and how well we want it to function and what it's going to be in. So that's kind of the scoring system. And again, we may revisit this after we build the bot. You go through, you start to do it, and you begin to realize that, um, we need to throw it back in. It really is important. Or you may begin to do it and start questioning the requirement again. We really need that in there? I'm not so sure. Maybe let's see what it's like if we actually take it out now based on what we're seeing. So this is definitely something that needs to be revisited. And this is something every engineering team should go through. They should come up with their own scores, maybe a bunch of weighted scores, look at those things, and then decide in or out, in or out, in or
By the way,
out. Okay, the
do you
torso.
know if any
Mhm.
other of the humanoid robot company they have any data like publicly? Because if, for example, you ask it perception AI if they have how many degree of freedom, they don't tell us how many degree of freedom they have it.
Yeah. We don't know. I mean, we can see the evolution of what's going on. Um, so when we get to the torso, this is going to be an important one because um, the first Optimus design basically dropped what is the pitch axis right here. The one that I put down is toxic. And the reason is it's redundant, as we kind of pointed out a little bit earlier, is that you can get the same thing just with the movement of your legs. Now, many other robot companies, I think just about all of them in China, have put all in their spine all 3 degrees of freedom. I mean, some of them are a little bit different. Some have no, or they maybe only one yet. But for the most part, Unitree and the others, it seems like they have all 3 degrees of freedom there, and they even have them up high. And that might be nice because it means you can really fold up really well. Um, but it almost seems redundant. In some cases, you may need it. So, ironically, Optimus has taken that joint out, very much like what Figure has done, you know. But the Optimus um, pitch in the leg down the hip is down very, very low. And because it's down so low, it's almost they almost actually need it in the spine because they don't it it's where it rotates at a long point. It doesn't rotate where the hip is. It rotates like below the hip significantly that you would almost need it. So it's very rigid from where its leg rotates all the way up to its head. Makes it very hard to get in and out of the car. The first figure bot also had that similar design. That the striding axis was down very low, but they had a hip that moved around. They made this really nice, um, sorry, the torso or spine that was able to do 3 degrees of freedom in there. So they had them all. But then they changed their design. In the changing of their design, they lifted that axis up very, very, very high in the hip, so high that it's like, man, it's practically right where we'd want to put the spine pitch anyways to throw it out. So to me, that is kind of a toxic one that you can get rid of. Then the tilting left to right, to me, that feels unnecessary. The only reason it might be there is it might somehow help with balance or walking. So depending upon how well your bot has to walk, you may need to put that in. But it's one of those things that almost feels unnecessary. Um, and then the twisting, that's one of those things that some have it, some don't. It's kind of nice to have in, but it's one of those optional things. It'd be nice to have, make life a little bit easier, but you don't really need to have it. And you were like almost like a hard, no, you don't need any of these things. And that's okay. I mean, we're definitely in agreement here. This is a pretty close, although we're close here. I mean, toxic out, it's basically the same thing. But I will have a little option on the movement of that because the twisting and potentially the lean can be very important to a very efficient stride. Can be very important to that. They're not necessary for walking, but it's one of those things that can help. And if you're running the Beijing half marathon, that might be the difference between winning and losing. Okay, because that little subtle thing. Okay, okay. Then we come down to the leg, and the leg certainly gets quite interesting here. The leg is very much like an arm. So we because it's bipedal, we agree we need to have it, and of course we need to have a hip. We're going to have a leg. Um, and the most important is this. So that's why it gets an I. It's indispensable. In order to walk, you need to have that. And if anyone has seen a toy walking robot, and I'm talking about the wind up ones that I had when I was a kid, I don't know if you can even find them anymore, you will see that it has, that's what it needs to move. It's just going back and forth and back and forth and back and forth. So it's absolutely indispensable for walking. You absolutely need to stride. These others, well, let's see. So we have the splits, the abduction going back and forth, out, uh, which is kind of an optional one that you is very important to balance. It's not important to walking, it's just important to not falling over, okay? So if you get pushed or something like that, it's one of those things that will be very important to catching you to make sure you don't fall. The role that you listed as kind of toxic, um, believe it or not, is actually kind of necessary. It's there a little bit for balance. It can help a little bit of your balance, but the real need for that thing is turning. So the next time you walk and you go around something, you'll begin to realize that, oh, you have to kind of make sure your foot is pointing in the new direction of motion that you want to go in. You take that out, it's like really hard. So again, those mechanical wind up robots, they were terrible turning. They would just like kind of walk forward. It's like, well, how do you get the thing to turn? And so if you see a robot shuffling like that, going around, it's probably because it doesn't have the ability to do that. So that's kind of why it's needed, even though it seems like it's not important. Um, and you may want to have it in it. So, but the other thing is that you could be right on some of these things depending upon the application. So, for instance, we've seen a lot of these Chinese bots wanting to show how good their systems are, moving around on very uneven terrain. I mean, they're being pushed over, knocked over, stuff like that, and you can see that they're going up. Things are just kind of falling apart, going out of the way. Not just stairs, but out in the ground and everything else. Um, let's see. You have a house cat, right?
Yes.
When was the last time your cat was set outdoors?
Oh, all the time.
Okay, so it's not really just a house. I mean, there's some people that have huts. Well, let me ask you, when's the last time you walked on uneven terrain?
That's a good question. I feel like it's all even
It's
terrain.
yes. So you haven't gone for a hike in the woods recently, but I mean, you've been out and about and everything. You've been through your house and stuff like that. There really hasn't been uneven terrain. You had to go up and down some stairs. Everything is flat. I mean, the world is designed to make it very easy for you to walk and not have to worry about it. So if this is a domestic bot that's going to be in your house, then we're really not going to send it outside. It's just in the house to do work. We're not going to send it shopping and something like that. It's not necessarily going to play, soccer with the kids in the backyard. So it's in the house. So we might be say that it's in a different environment where some of the joints we put in the leg will depend upon that kind of use case. And so we might be able to rule one of these things out. And if it's very urgent for it to get around very quickly and to change direction, you might say that's very important. We do want to make sure it doesn't fall over all the time. So that could go to, maybe to need it or important because we don't want it to lose its balance. So someone might come in and just say, sorry, boss, there's no way we can make this thing stay up and not fall down without that one. You just got to put it in. And in which case we might have to relent and put it in. Now, the knee, you thought that knee is important, right? I'm saying, well, it's kind of needed, but it's absolutely not indispensable. Absolutely not indispensable. Because I want you to stand up right now and walk around your room without bending your knee. Can you do it?
Yes.
Yes, you can. You see, we can walk without our knee bending. So if the point of your leg is to walk, you do not need a bending knee for bipedalism, or at least, you know, you need it for efficient bipedalism, but you can get around without it. So that's kind of the way I look at it. Say, okay, it's needed, but not necessary. Now, there's other reasons we would need this and other reasons we would need these. The bipedal bot is not just going to walk. It might have to squat. It might have to actually get down the ground to pick something up. And if when you get down the ground to pick something up, you actually need abduction. You need your legs to kind of split apart so you can grab the thing that's right down underneath you. So that's where and of course your knees critical to that. If you need to pick up something off the floor, I need a knee to be able to do that. So if you're just talking about walking, don't necessarily need it. Yeah, it makes it more efficient, but you can walk without it. Just go to the circus and you'll see like those guys up on stilts, you know, they're they basically don't have a knee. They're getting around fine. And then that brings it down to the ankle. So the ankle is again kind of like when you're talking about the wrist. How important is it? It is like your ankle is completely optional. You can walk around, especially if we're talking about an unsteady surface with just a ball on your foot. And there are examples of like some of the humanoid bots when they first came up, they didn't even have an ankle. They just like they basically put a soft ball on it so it could go around. So you could walk around that way. Your bot could be set up that way. It's not necessarily indispensable. It's really is optional. Um, Now, of these three axes, I'll start from the bottom here. The blue axis that I talked about, the rotation along there, it's talk. You don't need it. Um, you won't even find it in your body. You're going to find it's very hard. You can kind of do it a little bit, but not very much. If you do it too much, you're going to cause an injury on your knee. You're going to have like an ACL tear or something like that. So you definitely don't want your foot below your knee moving. It's not necessary. And so that's a wasted degree of freedom that you don't need to have. The flexion, again, is kind of optional whether you need to have it, depending on how you design it. But it's not necessarily indispensable for good walking. Yeah, it's kind of there, and for walking on uneven surfaces, yeah, it's needed. But it's almost like you don't necessarily need it. And the roll left to right, again, you almost don't need it. The only reason you need it is sometimes if you're walking on an unsteady surface or a surface that's not level. The other possible reason you might need it is that if you spread your legs apart, you sweep them out, your feet are going to suddenly no longer be level with the floor, and they need to rotate to stay level, right? So if you go way out, spread your legs way out, you may need it, and something like that. So that's like the only reason you need it is if you need to have your feet flat. And so looking at the use cases, okay, is it necessary or is it not necessary? So that's kind of where I am, and there's no like score that we have here. It's just what I want to do is look at your ideas and your thoughts on it, compare them mine. Hopefully, everyone who is watching this is kind of doing the same thing and having the same discussion of how important that is, really thinking about it.
Maybe a quick
And
question.
yeah,
If you ask about the like figure, for example, in this company, which one of these they can argue with you? Because you ask this question many times. Like if you
mhm,
remove that, what you think? So from this list, if you ask one of these, let's say figure or any of company that you would choose or pick, they would be argue hard with you on
right.
that.
And again, it depends upon the use case. So if you're just moving boxes around the factory and that's it, then you could probably take lots of degrees of freedom out of your arms, out of your wrists, maybe even in your legs. You could actually potentially take the knee out, unless it has to stoop down to pick up boxes. But if it's always picking up boxes from the same place, same height, and you remember most of these factories, things are set up to be ergonomic. We don't want people stooping down picking things up off the ground. The conveyor systems and everything are at ergonomic heights. They can come over and you bring it over, and that's what you're doing left. And it's like, the only reason you need to stoop down is because you dropped something. You drop it, you gotta go pick it up, move around. But assuming you don't make those kind of mistakes, it might say, "Hey, guess what? You really don't need the knee in that thing. And that fancy foot, you don't need a fancy foot. Maybe just put a big ball on there, or something like that, that won't slip a little bit, takes a little bit of the impact, but you don't even need the rest of the stuff." So you could find yourself taking joints out, taking joints out. The thing is, suddenly it's no longer general purpose. Suddenly it's like, oh, I'm getting myself more into a specialized bot for a particular situation. But it may be it's like, well, I've got a bunch of logistics companies, and a lot of those companies are pretty big, and they're willing to order a 500,000 bots. Well, I think for a 500,000 bots, and they want to have low cost or something like that. We can strip all sorts of things out, and it would be worth it. But if it's for, oh, we're only ever going to sell 500 of them, you might be, that's not worth it. It's not worth all the design effort to go into that for just 500 bots when they can just go ahead and take the one that I have that's more general purpose and it will work fine. So that's the only reason you wouldn't go in there. And you'll probably see that because when the industrial robots first came out, they all thought it was going to be one size fits all. And go to every manufacturer's catalog and look at all the different sizes and types of robots. You got the articulated robots, you get Cartesian robots, you get stair robots. You got all the small, big, heavy payload, um, 4 axis, 6 axis, 7 axis. I mean, different kinds of wrist designed for spot welding, wrist designed for painting. And so it's like, man, they can't even settle on the same kind of wrist, and that's because it turns out that sometimes they really had to get focused and very specialized in something. And so you will probably see that in the humanoid bot space at some point. But right now, um, it will be too costly to have too many variations right now. Partly because I don't think it's going to be easy to move the training data from one robot embodiment to another. I'm not convinced, if take the extreme example that figure solve it tomorrow and they say, we get everything, or AI is absolutely great, stuff like that. And they go, oh, great. Let's go take your end-to-end stuff and go ahead and put it into digit. It's like, that's not going to work in digit. no, completely different. The size of the bot, everything else. And then it's like you would almost have to go through it again. So these companies are not going to come out with different height bots right away, bots with different degrees of freedom, because it may turn out that it takes too long to get the training. And we're already seeing that, with full self-driving, it's having a problem going from the normal sedans up to the bigger vehicle. It just doesn't handle as well. And the reason it doesn't handle as well is because the vehicle dynamics are different, the mass is different, the way it's like there's all these differences. And so it's just like it just can't take what works for the smaller vehicles and then move them to the bigger vehicle. That's gonna be the same problem you're gonna see with the humanoids. It's gonna be hard to go not just from like one company to another, but it's also going to be hard to go within the company if you make too many changes. So when they go from one generation to the next, they're probably being very careful about these things and wondering, it's like, okay, are we going to be throwing everything out and starting from scratch again, or do we have enough of a foundation that we can kind of move over?
Maybe a quick question for the NJI, the recent video, the robot was outrunning the robot. Do you think it's toxic? Like the way they show the running. I'm not sure how many hours were lost, but um based on what you saw, do you see something that he can spot and tell us it's toxic?
Oh, okay. And the run, yeah. I just get a couple of glimpses. Man, it's like I'll say, if there's anyone from China that would like to invite me over for that marathon to take a look, I would because
You do
I
it's still running. You do running, right?
well, no,
You still
it's been a while. So I used to run marathons when I was younger, and done half marathons. And the half marathon is a very interesting choice for this reason. Is a half marathon is a little bit more than two 10Ks, and I'm really surprised that they didn't start with a 10K, because that seemed like to be a more achievable kind of problem. And there may be some bots. I mean, 10K would still be tough for a bot to make in one charge. A 5K, I'm pretty sure one of them will be able to make it. But for this half marathon, they're allowed to do either battery swaps or actually swapping the robot. And I can understand why they had to choose both, because not all the bots have swappable battery packs. Some of them are not designed to do that. And there's a 10-minute penalty every time you do that. I don't agree with that. It's like changing cars in the middle of an F1. It's like, come on, that's cheating. The whole idea of the F1 is to find out whether your car can handle the rigors of the entire race without breaking down. And so changing a bot in the middle, it's like, oh, I don't like, the battery packs I can understand. If you look at a marathon, we hand water and snacks out to humans when they're running. Okay, so why can't the bot get kind of like the same thing? What I really want to see is whether the bot can actually make it through that whole thing and not have parts falling off of it when it gets to the end, because that is going to be absolutely rigorous. So that's part of it, and it's pretty clear none of them are going to make it in one charge. I don't think they can go 13 miles, which is what it's. There's 13.2 miles. Like I say, it's about 22 kilometers or something like that. Um, 10K, it's possible. If you look at the size of it, and I'm not sure how big the battery pack is. If you look like Optimus and Figure, they're about 1/30th of a Model Y. Model Y gets 300 miles of range in ideal conditions. So divide that by 30, that's about 10 miles, which would be what, 16 kilometers. So in other words, there's enough juice in those batteries to make something the size of Model Y be able to go 10 miles. Okay. The robot's a lot smaller, so you would think, oh, hey, it should have enough to be able to also go that distance. Fortunately, and of course, you don't have the wind drag or anything like that, and it's much lighter, but the walking is not quite as efficient as having the motorized vehicle and stuff like that. But it may be just getting there. So we could argue that based on the size of battery packs, and some of them are not that big, they might be more like 1 kilowatt hour versus 2 kilowatt hours. They might be able to go 5 to 10 kilometers, under the ideal conditions. But this is going to be good. And again, it's a really hard apples to oranges comparison because some of them look pretty impressive, like the engine AI looked pretty impressive, and then you saw it walk up to a dainty woman, and it was also smaller. I'm like, well, wait a minute. I thought it was bigger, and it's about 4'6", which I'm not sure what that is in metric, but that's shorter than the average woman. And so, yeah, you can make your bot run pretty far and walk really well if it's very short. It starts getting a bit taller, it's a bit more challenging. The other thing, is it a cheat to say, yeah, our bot's not going to have hands? Okay, something looks like hands on there, but come on, if we're trying to compare all the different, and if you put like figure openness in there, like, look, they're putting all this energy into having hands there, and they have to carry the hands, whether they're not using them. But the fact is, all that's in there. So, do they get to remove their forearm and put something else in there? Because it's just a race to kind of be able to compare. So maybe they kind of do that. So it's sort of hard to say. Still, I think it's gonna be interesting to see because I would like to be able to look at the different designs and the one thing about engine AI, oh, and actually I can bring a slide up. I think I brought this thing up. That's kind of good. We can talk about that. Is on the PowerPoint. I did post this out, and this was when I took a look at the engineering, their video. This is the original one that we saw, which seems to be taller. So it looks like they made it a bit smaller. But the other thing that's important is how radically they changed the hip. So we just kind of talked about those 3 different axes you want to have in the hip. And there's different strategies to whether the stride axis is your first axis or whether it's down lower, because that way the mass of the motors that are doing the abduction and the rotation are not being carried by it. It makes it easier for it to swing back and forth. So if we look over here on the original engine AI, we can see that the stride axis is that red axis right there. And the other axes are up here and they're very high. They made their hip very, very high because if you make it at the normal hip level, then this becomes so short, it's really hard to do it. And again, you can see if right up around where my mouse is, if that's where you'd like to bend your torso, well, you have to bend down there. You'd see why you'd almost want to put a torso joint in there. But if you change the order of operation around, which they did in this generation, you'll see the red axis is now here. It's the primary axis, and it's right at hip level, which is why they really don't need a movement in the torso. And actually, I didn't see any movement in the torso. I was looking really closely. I don't think they have any movement in the torso. If you look at Unitree, it has all that movement in there. So that's why it's able to do all these kung fu kind of moves and stuff like that. The big question is, how important are some of those other degrees of freedom to walking? Now, biomechanics is saying it's very important to the economy of walking and everything, just like kind of being able to coordinate all of it together. So for something like a half marathon, that may or may not be important. But clearly their hip design changed quite a bit. And remember how impressive this was already. They learned a lot in this hip design, and they're kind of standardizing on a hip that just about everyone else is moving to. This is like the PND Botics one because you see what I call here this anhedral angle, and I'll explain what the anhedral angle is in just a second. I actually have something for that to be able to see it. So if we look at this bot, you see this axis here, it put straight along there.
Sure. You didn't
Oh,
share.
I didn't share. Okay, let's go ahead and yeah, I unshared with it, but in my head I shared. Yeah, so in my mind I was sharing. So if we look right along here where we're able to rotate the axis, so we see that axis is absolutely horizontal. So that's the way it's set up. And if we want, we can put in an anhedral angle, which is let's say like 5 degrees. And if you look at that, actually let me make it a little bit bigger so it's more pronounced, maybe 15 degrees or something like that. So what you see is that is now kind of pointed down. And you might be familiar with airplanes. Airplanes have what sometimes they call a dihedral angle. In other words, the wingtips are kind of up higher. But when you get the fighter aircraft, they actually go kind of down below the center. That's what's called an anhedral. And so you're seeing that the hips are beginning to put in an angle like that. Boston Dynamics are doing it. P&D Botics is doing it. I think the Unitree bot is doing it, and then we're also seeing here the Engine AI has also decided that there's some advantages of some reason. I'm not 100% sure why you would need it. I can see some advantages, but the disadvantage is that once I have that angle angle in there, and once I start to move my leg, the problem is you see my leg starts to swing out. It doesn't swing straight. And in order for it to go straight, I then have to go ahead and take this guy and rotate it a little bit, and then also rotate this one a little bit to get my toes pointing forward. So once you do that, you need to have a compound rotation. Whereas if you don't have that unilateral angle, then only that one axis is needed to swing forward, and the other two can basically lock out. They don't have to do anything. Um, but and so the reason they may be doing it is it may allow them to pack these servos in a little bit closer. They're kind of long. That way, if you do it up a little bit like that, there might be a little bit of space. So that's a suspicion. That's probably the reason they're doing it. It's packing. And I said, like, oh, in order to do that, that means these motors have to engage and do something. Turns out the motors have to engage and do nothing. Okay, not something. So when you're locking them in place, in order to do nothing, they actually have to do something, and that something is they have to draw current to go in there, 'cause it's not like they can just lock themselves and have a brake to hold them in place. They still have to apply a torque to not move, okay? Because there's going to be all these other forces on them that needs to kind of put them in there. And so it might be like, it's not actually consuming any more power by doing that, so, let's just go ahead and decide to pack a little bit to it. So I have a feeling that's why they did it, even though when you look at it, you'd say, "Ah, now those other joints have to move." And it's really not that hard in software to coordinate them together. It's like, if you need to coordinate them, you coordinate them together. Yeah. So, yeah, and
I
that's
I think it was first of all, I want to say thank you. I think the first thing, I think your teaching style, I appreciate the fun that the. I think we have to start a real company just for
oh, okay.
yeah. We should be
So
should
maybe we
we
should
should
really call it Decision Technologies Inc. Yeah, for 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 people who
for
can't make
real make it
decisions.
for
Yes,
real.
people have a hard time deciding. Yeah.
We should do this for real. But yeah, I think I want to say thank you because as for me in faculty, I think I used to be also in academia. I'm still a bit I'm in sabbatical leave, but the way it's teaching, I wish I had this to be honest, in especially in bachelor degree. I hated the robotics classes. It was nightmare, and I think you also had some of the listening kinematics and inverse kinematic or forward kinematics, but this one was absolutely for me new style of teaching. I appreciate that. I
Mhm.
think it was really fun and engaging, and I'm sure that people listening and watching will appreciate it for sure.
Yeah, well,
Yeah.
what I encourage everyone to do is first of all, everyone is a biomechanical, whether you think you are or not. You're inhabiting a biomechanical system, you work with it every day. And a lot of times I'm going for walks and I'm just like always kind of wondering, like, oh, this is interesting. Why does my leg do this or that? You can study what you're doing on any task and understand it. And a lot of times we forget, we think a bipedal bot is all about locomotion. Yet, wait a minute, there's other positions, and you need to squat and pick things up and do other things. Oh, you know, if I take that degree of freedom out, am I suddenly not able to do this particular task that I need it to do? So you've got to think about all those different things and look at the degrees of freedom you have in your body and what's necessary and what's not necessary. The other thing is just using AI is such a great learning tool. I had a lot of fun. I just prompted them a question. I just said, "Oh, what do biomechanics call this joint?" So when I had to fill everything out, it's like, "Oh, well, what's that actually called?" And I wanted to make sure I actually get and I get really good descriptions in there talking about all these different things, what flexion is and flexion abduction. And then I also talked about pronation and supination, which I thought was like movement of one joint. You're like, wow, it's more of a combination of a bunch of them. I'm like, oh, really? So it's more complicated than I thought. So if you want to understand all these terms that you were hearing from the biomechanics, ChatGPT and other AIs can just give you really fun discussion. So hopefully this motivates you. Look at it. You got questions, just go in there and ask, oh, why is it there? What causes my hand to actually move up and down the way it does? What are the tendons that are in there? What are the muscles that are important? It'll tell you all. And if it doesn't explain it right, just ask it again.
When I speak to people like in lay term and about the hand, the simple thing, the middle finger, it doesn't move, it doesn't have too much. It just make us to wonder about this question, like our own body. We don't understand it,
Yeah,
and it's just. I'll be honest with you. It's just a bit of shame, at least for
yeah,
me,
yeah,
that
yeah, yeah,
I
yeah,
still don't know
Yeah.
anything. It's just like, wow, it's my own body, and you don't appreciate it. This thing that you don't understand it. Yeah.
And the first thing I did is, yeah, yeah. Because I was wondering how important the middle finger is to piano playing, and so I finally asked my wife, I said, "Let's go play the piano." So I watched her, I can't do it, and we were trying to figure whether she was actually moving and, like, she did get a little but it's fine, almost like she didn't really do it was more the relative positions of things. Now, there's probably, like, a concert level pianist will tell me, like, "You absolutely need it for" but for most people playing the piano, it's probably not. It's more like getting it now, you can't just have it and I think perception only does this or that. I suspect they're all together. To play the piano, you need to be able to kind of move them independently. Now, whether you can get away with a stiff middle finger and just make sure the relative positions of those are done right, that's okay. Because you do have some chords and stuff like that where things are coming together. I was watching her hands, like, oh, that's a pretty strange. You definitely, and not only that is you need to have your add and abduction, not just come back to relax. Sometimes it's got to go underneath. So, like, this thing where it's say, "Well, I mean, do you really just need it so you can cross your fingers?" Well, if you really want to be able to play the piano, you'd be surprised. You just look at the hand positions, it does get a bit weird. So, the jury is still out on what you need. I suspect you if you just wanna have something to be able to entertain you, um, that's probably good enough. But if you want to be concert level, mm, then you probably need to have a little bit more movement in that middle finger. No doubt about that. Yeah, and I think I'll give you one bonus thing here, which is interesting. When I was doing the research and trying to understand a lot of the foot movement, especially like the rolling of the foot, and sometimes the movement. And again, there's this really combined movement that you have with your feet that is combining subtle movements of your feet coming, striking the ground, pushing off, and everything else that really absorbs energy and gets it back to the system. That also goes back to the hip. So when we talk about the the different axes there being important or not important, it's like they're all important to really being able to do the locomotion that we have. There is this ballet that's going on, concert almost, if you want to think about it. And they talk about pronation, that when you do walking, your toes are going to pronate or supinate, which means they're either going to kind of toe in when you finish your stride or they're going to go out. And depending on your arches, if you have very high arches, you tend to supinate a little bit. And if you have very low flat arches, when you come off, your toes tend to go out. And people that have sort of normal, everything stays there. So you don't have that pronation of what's going on your stride. And I just kind of noticed it said something about people with low arches are prone to pronate. And I just laughed at that. I was like, holy cow, it just made a dad joke. And I was thinking about that and it's like, okay, did it make a dad? And I actually got into a discussion with ChatGPT about this and say, all right, was that like intentional? Was this and it actually ran its own little scientific and says, well, if you actually read the literature, because I asked it, should you have said prone to or tend to? People who have low arches tend to do that. And it said, tend to is more neutral because prone has more negative consequences, it turns out. And in medicine, that's how the word prone is basically used. They talk about it, so it has they're more prone to have this kind of issue or that kind of issue. I said, yeah, but you probably learned about all this stuff from medical literature. It's like, yeah, you're right. Yeah, you're right. In the literature, they would do that. It wasn't like a bunch of professors sneaking in this pun in the textbooks saying, yeah, little arches, prone, which could have been a possibility. But it seems like because it read that in the literature, it came in. That's how it came up. But it ran this thing says, well, if I was going to do a scientific, however, if I was talking as a layperson, I probably would have said tend to. And then it said, yeah, but what if you wanted to be witty and joking? Yeah, prone. So it was really because I was trying to figure out, it's like, why it's word choice. It was very interesting that it came up with that particular word choice. And I wanted to know, did you have a sense of humor? I know people like me, if when you're forming a sentence like that, the end of the sentence is pronation, right? That's in your head right now. So as you're going along and you're struggling to find the words to put to get go in there, that would probably pop to the top of the queue because you heard, that's kind of in your head already. And even ChatGPT said, it's possible I could have. subconsciously picked that just because of it. So it's not even sure itself because it said, it has a high score no matter what. It's a good word. It's not like a word that you're trying really hard to get in there. It's out there. So it's interesting to see how these LLMs work, and also helps us understand our own thought processes and where they come in from. Realizing that a lot of people who pun, we're kind of wired in a particular way that are we're kind of forced to choose those things because the connection is just kind of made. Um, and there's also, I know, it's a famous um, British actor, forget his name, but he's able to do anagrams, take like anyone's name and like instantly come up with anagram out of a thing. And it's like, it's amazing how fast he does it. And he's just wired that way. He doesn't know. He just had it as a kid, to able to do it because, again, we see these kind of weird patterns we're able to pull out, and it's wondering how much the LLMs reflect what we're doing and how much is just chance. So that's my bonus. Interesting reflection on how an LLM works. Yeah.